Good.
It's just going over, I apologize for being a few minutes late. I was just going over an extremely interesting trig problem that I had not run into in 6 years of tutoring trig.
Wow.
Yeah. It looks like a simple problem. Express this as a sinusoid function. In other words, make that look like that. Believe me, it's not easy to do. It is very, very tricky. So, what do you got today that you want to work on?
Well, we started doing like sequence and series with geometric and arithmetic kind of stuff. So the first one I had a question with is state whether the sequence converges or diverges.
I'm having a hard time hearing you, Lucas. I'm not sure why.
Hold up. I don't know.
Everything.
Is that better?
Well, let's see. Everything was a little garbled. Go ahead and talk, and I'll see if I can understand you.
State whether the sequence converges or diverges. If it converges, find the limit.
Okay.
And then it's an equals 4n squared minus 3 over 2m squared minus 5.
All right. I'm trying to figure out where to begin. You know the difference between divergent and convergent?
Yeah. Divergent, it goes to infinity, basically. And then convergent, it gets closer and closer to a single value.
This series here? Is that diverge or converge?
Diverge.
Actually converges. And it converges to 1. If you take a square and you divide it in half, and take the other and divide it into half, and take the other and divide it into half, and half, and half, and half, you can see that the sum of this infinite series is 1.
Yeah.
So the sum of this series would be 1. Well, interestingly enough, what do you suppose the sum of this series is?
That one diverges.
This one diverges. And I always found this extremely fascinating as to how come the first one converges and the second one diverges.
Because it's like adding fractions that aren't like...
Yeah, the one way to think about why this is because when I take the first series, if I add up all of the terms that follow the 1/2, they don't equal 1/2. They're less than 1/2. If I take the second series, these two terms are greater than 1/2. These two terms are greater than 1/3. These two terms are greater than 1/5. So as I go to the right, I'm always adding something that's bigger than what I started with. I started with 1/2, and I'm adding 7/12. and then I'm adding two numbers that are greater than a fourth, so I keep adding bigger and bigger things. So this one goes to infinity and is divergent. But you won't really learn why until you get to calculus and you start studying infinite series, which is, I gotta say, it's one of the most difficult subjects in calculus. Analyzing these infinite series and determining whether they converge or diverge.
Yeah.
Okay? Well, one of the things that's absolutely necessary for a series to converge is that the nth term is 0. Well, if I look at this function you've given me here, and I try to figure out what the nth term is as the limit as n goes to infinity, well, I'm amazed you're getting these kind of problems already. Because I wouldn't think you'd get this until calculus, or at least limits. So you must be studying limits also, in addition to arithmetic series and geometric series. This is a limit problem. And if I want the limit of this function as n goes to infinity, I take the ratio if the powers of the highest degree polynomial in the numerator are equal to the power of the highest degree polynomial in the denominator, then the limit is 2. I don't care about this minus 3. I don't care about that minus 5. The only thing that determines what happens to this function as n goes to infinity is the highest degree polynomial, which is n squared on top and n squared on the bottom. So the limit of this whole thing would go to 2.
Oh, yeah.
That makes it divergent. You cannot have a convergent series unless the limit of the nth term goes to 0. In other words, when I had this series here, that's basically 1 over n as n goes from 1 to infinity. I assume that you're familiar with that terminology now?
Yeah.
Okay. Notice that that's 1 over n, right? In other words, when n is 1, I get a 1. When n is 2, I get a 1/2. Excuse me. This is 1 over n squared.
Okay, so for a question like that, and it's n over n squared, would it be
0.
0?
Yes. The nth term is 0. Now, boy, I don't know what you've learned and what you haven't learned. I know you haven't learned the full calculus curriculum, so I'm not quite sure what to tell you or what to talk about. The fact that they've given you this and ask you whether that's convergent or divergent, well, we really need to figure out what the nth term is. And when I say that, we need to figure out the limit of the nth term as n goes to infinity. And that's always going to be, if I have n squared over n squared, it's always going to be that ratio. Well, that's 2. And if it's not 0, it can't converge. One of the tests for convergence is that the nth term has to be 0. The limit of the nth term as n goes to infinity has to be 0. Well, just because the nth term is 0 doesn't mean it's a convergent series. Notice that these two series that I listed, the nth term is 0 in both cases. The limit of the last term here is 0. The limit of this last term is 0, but this is a convergence series and this is a divergence series.
Yeah.
Just because the limit of the nth term is 0 doesn't tell you a lot. It just tells you that it's possible for it to converge. If you get the limit of the nth term as being 1, or some number other than 0, then it's absolutely a divergent series. End of problem. Well,
Okay.
the function that you gave me had an nth term that went to 2, not 0. So I instantly know that it's divergent.
Yeah.
Do you have another one?
Yeah, well, the next one is 3n minus 5 over 4n squared plus n.
When the degree in the denominator is greater than the degree in the numerator, then I know that the limit of a sub n as n goes to infinity is 0. That alone does not make it convergent. It just means that it can be convergent.
Yeah.
And is that the question with this problem also? Is this a convergent or a divergent series?
Yeah.
When you get to calculus, C, they give you 10 tests for convergence or divergence. You have the nth term test, you have the P-series test, you have the integral test, you have the ratio test, you have the root test. You have 10 different tests as to whether a particular series is convergent or divergent.
Yeah.
I don't know which of those tests you've been taught. So I'm not quite sure how they want you to answer this problem. What do they want you to use to determine whether this is convergent or divergent? In other words, I can tell that the limit of the nth term is 0, but that doesn't answer my problem really.
Yeah.
It merely tells me that the limit of the nth term is 0. It doesn't tell me I have a convergent series. So I'm not sure what they've taught you. What do you suppose they want you to use to determine whether this is convergent or divergent?
Well, today in class we were just kind of doing, like, finding the first couple values and
All right.
working from that.
In other words, you're really looking at this.
Yeah.
Okay. So what's the first term?
The what?
What's the first term? In other words, this sigma means I'm going to end up with a sequence of terms and I'm going to add them all together. This sigma means I'm going to add them all together. There's also a capital pi that means I'm going to multiply them all together. So there's two types of math symbols that you're just learning. The sigma means adding. So the first term would be where n equals 1. What would that first term be?
Negative 2/5.
Second term.
That would be 1/18.
Third term? I think it's that. Notice that every term is getting smaller. And if I continue this series all the way to infinity, I would see that the nth term is approaching 0.
I think it started with -2/5 and then...
Well, when n was equal to 1, the numerator was -2.
Yeah. And then after that, it jumps up above 1 and then...
Right. So every term after that is positive.
Yeah.
But as we go to the right, we can see we're getting smaller and smaller. Right?
Yeah.
Well, no, hold on a second. Just a second. Are we? Let's see. Here n is equal to 1. Here n is equal to 2. Here n is equal to 3. So we have 4 over 36 plus 3, 39. Actually, that's not smaller than 1/18.
Yeah.
1/18 is 2/36. This is 4/39. We're getting bigger. Let's figure out one more term. If this other term gets bigger, we'll know it's a divergent series.
Yeah.
What's the next term when n is equal to 4?
12 minus 5, so 7 over
64, 68.
Let's see, so double 39 is 78.
78. So is 7/68 bigger than 4/39? And I believe it is. Just pull out my calculator here. 4 divided by 39 is 0.102, whereas 7 divided by 68 is 0.1029. So these are getting bigger.
Very slowly.
Yeah, very slowly. But as long as they keep getting bigger, the nth term can't be 0.
Yeah.
Which means this is a divergent series.
Yeah.
Now, like I said, that when you get to calculus, there are 10 tests for convergence or divergence. And I mean 10, and it's really hard to work through each one. But one of those 10 tests is called the Nth Term Test. And it's the simplest one. It's if you can prove the nth term is not 0, then you have a divergent series. Well, we can see that every term, this term is bigger than that term, this term is bigger than that term, this term is bigger than that term. It doesn't matter if it keeps getting bigger by a smaller amount. I can tell the nth term is not going to be 0. It's not getting smaller, it's getting bigger. And if the nth term is not 0, then it is not a convergent series. It's a divergent series. By definition. But what I say to you kind of has a lot to do with what they've taught you. And I don't know what that is. I'm a little surprised that it's this far advanced already. What have you been working with in addition to these series here? Have you worked with limits at all?
Not much.
So they haven't given you this problem.
Well, not recently. I think we might have done that
What is that?
earlier on in the year.
You know what that limit is?
It's 0.
Uh-huh. All right. All right. What's the next problem you have? Maybe I can kind of figure out what they've taught you based on the degree of difficulty of the problems you're giving me.
It is. The next one is series. So write in what is that E looking Greek symbol? Is it sigma? Write in sigma notation 2 plus 5 plus 8 plus 11 plus ellipsis plus 53.
Excuse me. 2 plus 5 plus 8 plus 11 plus 14?
No, it's an ellipsis, and then it says 53.
I'm not sure what you mean.
So like after 11, there's an ellipsis.
Is that what you mean by an elliptic?
Yeah, dot, dot, dot. And 53.
All right. This is an arithmetic series.
Yeah, because it's
Common
like
difference is 3. So if I want to write this in sigma notation, and I say n plus 3, and I let it start n equal 2 to infinity, do I get that series?
Yeah,
Exactly that series.
but you don't get the end, like where to stop.
Well, the n where to stop is infinity. This thing doesn't slow down. It gets bigger every time.
Yeah.
So this is definitely a divergent series. Now, there are some choices. It doesn't have to be this. I can actually make it look like this also. By doing what? Let's see. If we took, how do we get a first term of 2? Must
3n minus 1.
Well, that gives me a first term of 2, a second term of 5, and a third term of 8. Very good. These are a little tricky. But you're right.
Yeah.
Those two series are the same series. The only difference is that this one starts n as 2, and this one starts n at 1.
In the second one is geometric, not arithmetic.
No, they're both arithmetic. Arithmetic means there is a common number difference between each number. This just means there's a bunch of numbers between 11 and 53. Okay? But it's not geometric. Geometric is there's a common ratio between each numbers. A geometric series would be this. Everything is multiplied by 2.
Yeah.
As opposed to this one where I'm adding 3 to every term. Remember that series that I said was convergent? This one?
Yeah.
That's a geometric series.
Yeah.
Everything is multiplied by 2. That's a geometric series that is convergent. And you will find that any geometric series where r is less than 1 is convergent.
Yeah.
In other words, if r is 1/2, then I have 1/2 plus 1/4 plus 1/8 and so forth and so on. But if r is 1, I have 1 plus 1 plus 1 plus 1. That's divergent. The nth term is 1. And if r is greater than 1, say 1.1, then I have 1.1 plus 1.2 plus 1.4 plus, they keep getting bigger. And if they keep getting bigger, it's divergent. So the only way this is a convergent geometric series is if the absolute value of r is less than 1. That is one of the tests for convergence, is if it's a geometric series and r is less than 1, it's convergent. But there's a lot of series other than arithmetic or geometric. You got all kinds of series. The series you gave me, where it was 4n squared over 2n squared, that's neither arithmetic or geometric. That's just a power series. What else you got?
The next one is 5 minus 15 positive 45 negative 135.
That's all I need. Is that an arithmetic or a geometric?
It's geometric, and the base of the exponent is going to be negative.
So -3 is the multiplier.
Yeah.
Okay. So what's the problem here? Write it as a sigma?
Yeah, and then find the n value for 3,645.
Okay.
Yeah.
Well, let's figure out how to write it as sigma. Hold on. Hold just a second. It's an alternating series, and an alternating series always has a -1 to the n. But our multiplier is 3. Let's see, if n goes from 0 to infinity, the first term would be 5. Second term would be positive, but it would be 3 squared 45, so that's not it.
I get it.
See, that gives you -15. And then the third term, where n is equal to 2, would be 5 times a positive 1 times 9. And then the fourth term would be n equals 3. So now I get negative again, and 5 times 3,
27,
which is that number right there, -135. So that works for the sigma notation. It may not be the most efficient notation, but it works. It defines that series. Now, how do we figure out which term gives us 3,645? Well, let's go back and talk about the nth term definition for a geometric series. The nth term definition is the first term times the common ratio to the n minus 1. That is the explicit formula for the nth term of a geometric series. Well, what do I know here? You told me that the nth term was 3,645. I can see that the first term is 5. I can see that the common ratio is minus 3. So I merely have to solve this problem for n.
Okay, so
How do I solve that?
divide 3,645 by 5.
Okay, that's a good first step. What does that give you? 720, what? Have a calculator?
9.
29?
Yeah.
So that's equal to minus 3 to the n minus 1. What's the next step for solving this?
Log.
Let's take the natural log of both sides. Now that allows me to bring that exponent down on the fraction line. I don't like that. You can't take the log of a negative number. Must be a way to turn that negative 3 positive so we can solve this. So let me back up to this step right here. There has to be a solution here. N has to be an odd number. What, I think this is the same thing. You know, I can't believe I've run into this for the first time.
I guess today is just one of those days.
No, the other problem I ran into the other day, I was just going through it with another trig student. But yeah, you're not far off. Thinking. Wow. How to solve for n? Somehow I got to get rid of that negative 3. What is negative 3 to the n minus 1? If I take the natural log of both sides, I'm going to have a negative argument That violates the domain of logs. So how do I solve this? I know that n has to be an odd number so that this exponent will be even, making it positive. Well, what's the solution? This shouldn't be that hard to solve. 729 equals minus or plus 3 to what power?
Well, it's 6.
It's 6?
Uh-huh.
Okay, so n has to be 7.
Well, and then I did -3 to the 6, and it gave me -729.
Well, it shouldn't give you negative. It should give you positive. If you take -3 in parentheses to the 6th power, you'll get positive 729. Watch. I'll bring my calculator up.
Oh, yeah, no, you're right. I didn't put the parentheses.
Okay, the parentheses are key there. So n, in other words, this exponent has to be 6, which means n has to be 7. So we've solved the problem, but interestingly enough, I don't know how to solve that problem other than trial and error. There must be something we can do here to use logarithms to solve this. I just don't see what it is. And I can't believe I haven't come across this before. This must be higher level logarithmic problems. I can't quite, I can break the -3 up into a -1 to the n minus 1, and then a 3 to the n minus 1, so I can do that. That's equal to 729. But then what I do from there, I'm not sure.
You can't just do negative log or 3.
If you take the log of both sides, you're going to end up with a negative number inside the argument of the log. And you can't do that. Wow. In other words, I can intuitively know that n is 7 is the solution to this thing, just because that's the only n that gives you that number.
Yeah.
But how you would get it, I don't know. Make that 728, and it's a much different solution. It's 6 point something.
Yeah.
But I'm not sure how to solve that problem. I'm not sure how to do this.
Hmm.
There must be.
I don't know. I'll have to ask my teacher.
Must be a way to take that n minus 1 and change it to an n. Gosh, I don't know how to do that. I mean, I can do it for this problem. It's n is 7 for this problem. But make this a super big number, and I'm not sure I'd be able to do it. Well, how did we do it? We figured out what 3 to the nth was. And then, so this is the same as 3 to the nth. No, because this n ends up being 6. So this n ends up being 7. Wow. I'm going to have to give that a lot more thought before I go further with that. I'm not really sure how to solve that, to be honest. Let's take another problem that you have.
All right. The next one is Q. Oh no. 117 plus 110 plus 103.
Hold it. 117, 110.
No, it's 117 plus 110.
It's a series, not a sequence?
Yeah, it's a series. Plus 103.
All right. What kind of a series is that? Arithmetic.
Arithmetic.
Because there's a common difference of minus 7. Every term is minus 7. So I can represent that by what? N minus 7, where n goes from 117, or actually 124. No, that's not it. Is the goal here to write it as sigma notation?
Yeah.
Something minus 7. So doesn't that work?
Yeah, I think so.
No, because the next n is 125. 125 minus 7 is not 110. So that doesn't work. The only thing you have to prove is the proof is in the pudding. In other words, you have to make sure that your series equals your series.
Yeah.
So how do I subtract 7 every time n goes up 1? So I must have some number, 117 minus 7n, where n goes from 0 to infinity. There you go. Now the first term is 117. The second term is 110. The third term is 103.
Yeah.
What else do they want to know here?
That's it. They just wanted to write it in sigma notation.
Okay. And sigma notations are not unique. That's not the only one I could have come up with. I could also come up with this one.
Yeah.
And going from 1 to infinity. Notice that gives me exactly the same series.
Yeah, but you just didn't adjust the...
Well, no. The only thing I did is I went from 1 to infinity instead of 0 to infinity.
Yeah.
But the series that both of these give me are 117 plus 110 plus 103 plus 96 and so forth. In other words, I'm just using this as a demonstration to show you that this series here on the left is the same as this series down here. The only difference is in one case n goes from 0 to infinity, in the other case it goes from 1 to infinity. So you can manipulate the n's. Say you had a series like this. Well, n couldn't go from 0 to infinity because the natural log of 0 is not defined. So I would necessarily have to have this series go from 1. Okay? Say you had this. Well, now I can't even have this go from 1. I got to have that go from 2. Because the natural log of 1 is 0, and I would have the first term being 1 divided by 0, which you can't have. So if you have this kind of a series, then you better be able to start it from n equals 2. So where n starts kind of depends on the kind of function you have and the series that you want to express. The reason series are so important is because any function like this can be expressed, not any function, but a lot of functions can be expressed as a series. In other words, if you want to know what 1 over 1 minus x is, you can approximate that by this series. And what do I mean by that? Well, let's let x equal 1/4. Okay, so I'd have 1 over 1 minus 1/4, which is 1 over 3/4, which is 4/3. So we know what that is. When x is equal to 1/4, it's equal to 4/3. But it's also, the first few terms of that series will approximate 4/3. How do I know? Well, let's see. 1/4 is x to the 0 plus 1/4 to the 1 plus 1/4 squared plus 1/4 cubed. Well, that's 1. So you have 1 plus 1/4 plus 1/8 plus 1/16 plus 1/64. You can see that this series here is honing in on that value 4/3. So that's why infinite series are extremely important, is that it allows you to approximate a function. This function here, I can approximate with this series. And I don't need very many terms to do it. If I took the first 5 terms of this series, it would equal this number probably to 4 or 5 decimal points. And there's other series. I can approximate the log of x with a series. I think that's, I don't know, x over n factorial or something like that. Okay? The thing is that I can approximate a function with an infinite series. That's the value of infinite series, because a lot of times you have no way of doing things with functions. It's difficult sometimes to take the integral of a function when you get to calculus, but you can take the integral of a series real easy. So if I can represent a function by a series, then it allows me to do calculus stuff on it that I wouldn't normally be able to do. All right, we got just a few minutes left. Do you have any last problem that you want to look at?
I think I have this pretty much down.
Okay. Yeah, it's a little strange that you're getting this at this point. I guess maybe not that strange. You're in pre-calc and you're doing arithmetic and geometric series, but you're looking at sigma notation. And not everybody gets the sigma notation until they get to calculus.
And it's just not, it's pretty basic stuff. It's not.
Yeah, it's not as hard as the calculus infinite series, which is like 10 times harder. I mean, I have one student that it took me a full year working on infinite series in calculus. Full year, once a week, to go through all of the different tests that you can do to determine convergence or divergence. And that doesn't even tell you what it converges to. That just tells you whether the series is convergent or divergent, which is the major question that you have usually when you're talking about series. After that, once you determine that it's convergent, you try to figure out what it converges to, what number. But the biggest difficulty is determining whether a series converges or diverges. And like I said, there's 10 very difficult tests that you apply, some of them being calculus, that you haven't had yet even. So,
Yeah.
Okay.
All right.
All right, Lucas, we're back on Wednesday next week.
Yep.
Talk to you then.
Bye.
Bye-bye.